in short. So I started as a electrical engineering in India. I completed my bachelor's in electrical engineering, and then I actually went on to work for telecom for a few years. Then I actually quit my work, and then I was trying to figure quite a few things out in my life as well. What is the right direction for me to go? But I think data was probably when this whole data thing was not that big at that time. This I'm talking about 2012, 13. It wasn't that big at that point of time. um, at that point of time, I probably realized that that was my calling, and that led me to move into this field. In 2016-17, I actually came to Australia to pursue my masters, and that is when I actually completed my masters in data science, and went on working in the core data field. I was previously coming with an ETL experience, so I was working as an ETL engineer before, and then went on to work in, as Yash also mentioned, I went on to work in insurance for some time. Worked in biogas as well, then worked for banks as well. So I was working for PwC for some time. So yeah, and then ultimately I worked in FMCG as well, Kraft Heinz, which is a big one of the biggest FMCG players. I worked there as a senior data analyst there also. So all in all, it has been quite an interesting journey for me. Quite a lot of learnings as well on the way. A lot of things and that you carry forward from your past learnings and your experience, work as well, studies also, that you carry forward, um, and yeah, having that experiencing in real life is a different ball game altogether. So I'm very happy and very thankful to Yash and Harshita for organizing this and inviting me for this event. Saturday is a good day. It's a bit relaxed for me as well, and hopefully everyone is having a good weekend as well. So I think it's so I live in Australia. I live in Melbourne actually. So it's 7:30 here. So I hope to have a good session with you guys. Share whatever my learning is currently, whatever I've learned, and the specific area that I'm working in right now, which would be more beneficial for all you guys to understand and learn also. So from a very practical perspective as well. So yeah. So thank you guys for that. And I've tried to I'll try to put together whatever relevant information that I could into the PowerPoint, and try and summarize as much as I can. You guys are free to question at the end, whatever question that comes up to you. Just let me know. Just reach out to me on the chat as well. And Yash and Harshita, they are there. If you can just let me know the questions as well at the end. I'm happy to answer. And to be honest, I'll be very honest. There could be questions which I would not be knowing the answer to, because how the algorithm works, right? There's so many things every day. There's something which is new happening, and you might learn something, you might miss out on something, and yeah. So I'm happy to learn. I'm learning every day. In fact, yesterday itself, at work also, there was something that I came across, and I had no idea how to deal with it. So I was working on the LSTM model, and I had a very theoretical knowledge about it, but then I actually went on reading about it, what it means and what it does and all that. I was actually reading that today also. So sorry if I'm not able to answer any question very specific. I would not want to go too much in the technical aspect, too technical details of the algorithms in specific, because I think for that would become a little too specific as well. But I'm happy to answer if any one of you have any sort of questions around that. I'm happy to answer that as well. So yeah, Yash, if at all you'd want to share the presentation, and I would continue from there on.
Yeah, sure. I'll do that. Give me just a second.
Thank you.
Yeah, I hope my screen is visible. You can just guide me when to change the slides.
Yep. Thank you for that, Yash. Yeah, we can move on to the next screen, please. So yeah, as I pretty much summarized about myself is pretty much all here. Worked in telecom, insurance, FMCG, and all that. So I've pretty much covered all of that. So ETL engineer, worked as a data analyst, and all that. I've worked in British Telecom in India. Worked in Manulife Singapore for a few, actually not a long time, 1 year maybe or less than that, I guess. Worked at Kraft Heinz and PwC. PwC actually was my last organization where I was working. So I was working in banking there. So banks were in specific my clients. So I was working in the risk analytics division, which in specific it wasn't more of the it wasn't more of a data modeling, I would say, but it was different sort of work altogether though, because risk obviously is a very broad area. So that it was. But yeah, I'm currently working as a data scientist in and Telstra here, and it's a pretty big player. So for a bit of a context for anyone who probably would be knowing or not be knowing about Telstra, is it's one and only one of the biggest telecom players here in Australia. And just as again, just giving context, combining all the biggest telecom players in India all combined, if that becomes one single body, that is how big Telstra is here in Australia. And they are at the forefront of all technological changes and advancements that they are making here. There's a lot of funding for Telstra in the field of AI in specific that is happening. And Telstra actually have their offices in Bangalore as well. So I work very closely with the Bangalore team as well, who work in specific for the mission that I'm working on right now. So yeah, that's pretty much about the details about my bit of an experience. So yes, if we can move on to the next slide, please. So yeah, as I mentioned earlier as well, what I'm going to in specific talk about today is the application of the machine learning and algorithms and AI in the field of supply chain as a whole. Now, everyone knows pretty much what supply chain is. But as you would see, as was the definition says on the screen as well, it involves the flow of goods and services from the raw materials to the final delivery of the product to the customer. It's a pretty challenging area, especially in any FMCG sectors also, or for that matter, I have come from FMCG, so I know what are the challenges working in the supply chain area. Currently, when I'm working in telecom sector as well, I'm working for the accessories supply chain team, which again has its own challenges, which is the problems are pretty much common, as you would see in any of the supply chain areas, but if you look from a data sort of a perspective, it changes industry to industry, and the problems are very varied. So you have to be very, very specific as to what exactly are you trying to solve in the field of supply chain. So it is very crucial for businesses to reduce costs and optimize efficiency, as you would see here on the screen as well, it mentions. So yeah, if we could move on to the next screen, please. So now, straight away jumping into the area of machine learning in supply chain, that if we want to talk about is that the machine learning algorithms today are used the most in order to optimize the various aspects of supply chain, and there are various various areas where it is applied. So obviously demand forecasting, inventory optimization, route optimization, all of that is there. But and you have to be very sure shot and be clear as to what you're trying to solve in terms of the problem statement itself is extremely important. So as the very first word that you see here is demand forecasting is the area that I am working right now in supply chain. So my area of work in supply chain is a combination of both demand forecasting and inventory optimization in total. Um, so um, so as I'm saying, the problem statement needs to be extremely clear, and um, and to be very honest, when I was studying data science at that point of time, um, when when the professors or the lecturers used to tell us that you need to be very clear about what the problem statement is. Uh, we never, I mean, we basically always undermine the real meaning of it, what exactly it means. Uh, but when you start really working in the area, do you actually get to know that it is extremely important why to have a clear cut understanding of what the problem statement is, because this is such a vast area of supply chain and machine learning all combining and getting together, that it becomes extremely difficult to focus yourself in one specific aspect. Because if you go if you change your path at any point of time during the mission, uh, everything falls off, because then you go on exploring about anything or everything, and you might come up with a lot of things, you might come to a lot of understandings about a lot of things which were a which could be a big potential, a very high potential for the organization, but that exactly is not the problem that we're trying to solve. So it becomes all the more very important to know what exactly are we trying to solve. So demand forecasting and inventory optimization is the area that I am working on, and that's the reason I was reiterating on this specific fact that when you would go into work in the real world, this is something which you need to be very clear about. Yeah, we can move on to the next slide, please. So as you see here on the screen, this basically is the flow of how you meet the demand and the supply, and how the procurement is done, and how to enhance the customer experience, and how to schedule the maintenance. And so this is basically a chain that follows in a whole supply chain process. So at the end of it, the most important bit to take from this particular slide, or in general, I would say, is to have the right product at the right time, for a better customer experience as well, and at the same time for the profit of the organization also. So it works hand in hand. Otherwise, there's a lot of loss which is incurred for an organization in general, and it is an extremely difficult problem to solve if you go backwards. So you have to be right at every stage for this to actually work. So the planning forecast has to be good, the demand forecast has to be good, the customer experience has to be good, the inventory optimization has to be right. Everything has to be in place. And as I'm working in the organization, and I know for the other organizations that I've worked as well, I very well know that if you are trying to forecast a demand, none of the organizations that I've come across has a demand forecast of more than 50%. So there's a 50% lost opportunity there, which is pretty big, pretty huge. And when you talk in terms at the store level forecasting, these small things add up to millions and billions of dollars. So that is very important. So everything has to be right at the right time. And yeah, hope I'm coming across clear. If there's anything that is not clear, I would definitely make sure that I clear that in the end. But yes, Harshita, if there's any pressing questions in between, please feel free to just ask me that question,
Yeah,
and we
sure.
can
Sure, Abbas.
yeah, we can move on to the next slide, please. Yeah. So as you see here on the screen as well, one of the most challenging problems in supply chain is the optimization of product distribution in stores and inventory. So this problem has to be approached from multiple dimensions, meaning thereby that you cannot just simply say that, okay, all right, the product which was demanded in one particular store was not there. Um, then where was it? Was it in any other store? Was it at the inventory? Was there less inventory in one store, or was there? Is that got to do with a higher demand, or is that to do with a bad demand forecast? So there are a lot of things that needs to be questioned and correctly answered to actually attack the problem. So because this is a very multi-dimensional problem that you have to approach from, so you have to be very sure of what you are of how you are attacking the question of forecasting. So as I said earlier, currently I'm working on the problem of finding out of stock um, or excess inventory situation at the store level. So basically, I'm trying to, if I put this in simple terms, trying to forecast that if there is an excess inventory in stores, which is also technically called as dead stock, or if there is an out of stock situation at the stores, and that is something which we are trying to resolve. So Telstra in specific is into the business of accessories as well. Now, accessories are could be a lot of things, right? Speakers, headphones, like screen protectors, cases, and Telstra also has its network. So Telstra SIM cards and all that. So all sort of these sort of things. So accessories do not in specific include the SIM cards and everything, but as I said, speakers, cases, screen protectors, headphones, these sort of things. So because we are dealing with such a high, such a huge sample of accessories, they have to be categorized. So between me and my team member, I have actually we have actually broken that down into different areas. So let's say I am dealing with speaker and headphones. My colleague, he is handling with screen protectors and cases, and looking at the excess inventory of the dead stock, or the out of stock situations at the store level. So yeah, that is what the main problem that I'm working right now in the mission. If we can move on to the next slide, please. So again, in approaching the problem, there are multiple steps which are taken before the model is built and optimized. The one of the very important steps is the data gathering from different centers. Now this is an extremely challenging task. A lot of organizations across the world, and I've worked at some of the very big organizations, and I've realized that one of the core problem is that the different data centers do not really, first of all, they're not integrated well, um, and if they're not integrated well, they do not talk to each other, and because they do not talk to each other, when you are trying to solve a problem um, for which you would need the data from different data cores, when you try to bring them together, and I'm trying to be as simplistic as I can in this, and if I'm too technical, please let me know, and I'll try and explain that in much more clearer terms. Uh, because the data is coming from different data cores, it's different. It's difficult to bring them all together. Now, why is that a problem? That is a problem um, because the way like, for example, I can give you an example. One particular item which is sold at a store level would have its record in one particular data core, right? There's one data center which will store the information about that. All right. Then there would be a different data core, a data center, which will store the information about the item ID. Like, for example, that particular item, uh, all its information from end to end. Like, for example, what the color, the capacity, or whatever information that is, right? Um, it's very difficult to bring all that sort of data on the same page and stitch them together, because let's say in the example that I gave, item ID is the only common criteria based on which you're trying to join them, right? But the way the data is populated in one data center is extremely different from how it is populated in the other data center, and very rightfully so, it would be. But when you're trying to solve a problem which requires the information from all different sort of data cores, stitching them together becomes an extremely difficult task, and that is the reason why we have to be very specific as to what we are trying to, again, coming back again to the same question, what is that we are trying to solve? Because once we are clear with what you're trying to solve, we get to know what we are trying to stitch together. And uh, and why is this also a problem is because as a data scientist, when you're working, you cannot have a straightaway access to all data cores. So you would need to have a parallel discussion from different stakeholders of the data cores to actually get you an access. So you have to raise a request, you have to give them an explanation what we are trying to solve. So there are different levels of access that they would give you, and then only are you able to bring that together. So it has to work in parallel, right? Otherwise, when you're working in an agile setup, um, is time is money, right? So you are working on a very tough deadline. You have to deliver everything on a daily basis, on a regular basis. So they run in sprints. So you need to be having regular discussions with the stakeholders, trying to get the data right, trying to understand the data as well, because as a data scientist, you probably wouldn't know everything end to end about one particular data set. So the schema or the tables, that the information is stored in one particular schema or table. So you would want to understand what this means, what that means, and what each of the column means, what each of the feature means. And it sounds very simple, right? You bring them all together, you can stitch them together, it's all fine, but it's not that simple. It's one of the most challenging tasks to solve. So that is the reason why it is extremely important to to have one of the important skills here is you need to have a very good command on SQL. You need to have a very clear cut understanding of how intermediate to advanced SQL works. I learned it on the job. I had a hard time learning SQL. I wasn't the best. Of course, as I mentioned, I was coming from an electrical engineering background. I did not have a very solid foundation for programming. But then I learned it on my way. So that is the reason I would say SQL is very important for a data scientist as a tool for them to bring data together and stitch them all together. So once that is done, and which depending upon the challenges that you would face at every stage, once that is successfully done and tested at all levels, and by me saying that testing at all levels it actually means that you need to keep validating the data every time. Now, what exactly validation means is that you need to be very sure that the data that you're trying to bring together, when they're all one snapshot of the data, has to be, so you pick up the data, so you join the data from all angles, you pick up the data from one specific period, and you try and validate that from the business. So you check with the business. So the business already has their own Power BI dashboards, they have owned their reporting system and everything. You get that data and you compare that with your own data to validate that, okay, all right, the kind of data that I'm working on, let's say supply chain in this case, is that the correct data I'm working on or not? All right, they may be working in a different reporting setup, but you are trying to solve a different problem altogether. So that needs to be very, very clear. You need to be very sure that your data is looking right. All right, so that is what it is, and as you see here is the whole data, once stitched together, is moved onto the cloud platform, and that is something which I will speak next also about. So this is it's a diagrammatic representation of how the AML looks like. So basically, so we'll talk about it later as we go ahead. So yeah, Yash, we can move on to the next slide, please. So so at the Azure ML platform, we have different what do you call, we have Jupyter Notebook. We have, which is, I think, from somebody who is proficient in Python, it's the easiest to work on, right? To do all the cleaning and analysis and all that you would want to do. It's a bit overwhelming in initially, because if somebody who hasn't really worked, nowadays the UI is pretty good, and you would catch that pretty quickly. But I do remember it wasn't the best at one point of time, and I've realized and I've learned that all along my experience. So the Azure ML platform is a wonderful platform to initialize your Jupyter notebooks and bring in all the data for doing all sort of analysis and clustering and everything. So how we do that? So now you have to understand, it's a I'll try and make it simple. So you basically have a data center, different data centers where you have actually tried stitching the data together and bring them all together and trying to validate everything together. But you need to create a pipeline from the data cores, the different data centers, and bring that onto your ML platform, which is Azure in this case, right? So that is where we utilize the power of Azure Data Factory. So ADF, what it does is that it basically creates a pipeline to bring in. So you have tested everything there on the using SQL. You have tested everything there on the let's say in BIW or data core centers using PostgreSQL. You create a pipeline, and using SQL, you bring all that data onto the Azure ML platform. And basically, here you have the power of utilizing your pandas and your Python code to actually, sorry about that. So to bring in everything here on Python, and then start doing all the analysis, bringing them all together, because that is the code which will finally be deployed in production, right? So you need to be very very clear, and in terms of the clustering or the analysis or any sort of things that you're doing from the statistical perspective on the Azure ML platform, that has to be pinpoint right, because yeah, you can, there's no error of mistake there. I can guarantee you that. There's no error of mistake there. So so you have to be very sure about that. And there are different time series models which are explored. So basically, as you see here, the Sarimax, LSTM, Facebook Profit, and there are millions of other models as well. But these are the ones which are used the most in the industry because these have been proven to perform the best in very adverse data situations for time series modeling. I'm not 100% sure how many of you guys are aware of how a time series model works. But essentially, in a supply chain situation where we are trying to forecast what is the availability of a particular, what is the demand of a particular item at a store level on a weekly basis, on a monthly basis, bi-weekly basis, that is something which we're trying to achieve. So, like for example, let's say today the demand for in a particular store, let's say Richmond is a nearby area. In Richmond, the demand for a particular Bluetooth earphone is let's say 94 units, right? Um, and we predicted, let's say, that the next day, based on the trend and everything, the demand is going to be, let's say, 96. All right, so 94, 96. So that is a pretty good. That's actually a very good forecast if we are able to do that. That is something which we are trying to forecast, right? Now, this I'm talking about one single item at one particular store, right? Now, multiply that by 1,000 stores and multiplied that by 1,500 SKUs. So SKU, if you guys understand, is a stock keeping unit. So one SKU, so 1,500 SKUs multiplied by 800 stores. So you understand the complexity of the problems, right? There's so much of data that you're trying to forecast. So we break the problem step by step. We try to forecast one item first. We see how the accuracy is looking like. Then we do for 10 items, like 15 items, 16 items. But we also have to look we do also have to have an understanding for the business as to what we are trying to forecast, which are the products, which are the items, which are of a higher, which give us which has a higher margin, profit margin. And those are the ones which we are trying to forecast, right? So for that, we go on actually the data which we have put together in a journal. We actually go on utilizing the power of Max, LSTM, Facebook Profit. Currently, I'm working on Facebook Profit. LSTM, I hope should give me a good accuracy. It's not yet, but I'm trying to tune it. So there's something which is called as hyperparameter tuning. So there are different parameters for a model based on how it based on how, and this is in very rough terms that I'm trying to explain, the different parameters which you parametrically change and adjust so that the forecast is accurate. So currently, let's say for example, in my case, the Facebook Profit model that I'm trying to use, my accuracy is somewhere around 84% or something like that. I have to beat that, and I have to move that beyond 90%. So there are different measurement parameters. So there is something called as MAPE, which is the mean absolute percentage error. Then there is MSE. Then there is RMSE, based on which there's so many things that you actually look at to finally decide that, yeah, okay, all right, my model is looking good. So these are the models that you go on using. I'm not going into too technical details for these models because otherwise this will become a maths class. I don't want to do that for any of you guys. So I wouldn't really do that. So that is done, and then once you are able to forecast and the business agrees that, okay, all right, you guys are able to forecast it better than what we are thinking, and which bringing everyone in agreement is a big challenge in itself. Is then the final model is put into production, and the output of the model is then fed into a front end optimizer. So that is how the whole problem is like. So yeah, we can move on to the next slide, Yash.
Yeah, Bas. I guess we are at the middle stage of our session. So why don't we
Yep.
take some questions and then we can move
Sure.
ahead?
Sure. Why not? Yep.
All right, because I'm seeing some interesting questions in the Q&A
Yeah.
section.
Yeah.
So
Yeah.
I'll
Sure.
just read them
Sure.
out for
Sure.
you.
Yeah. Yeah. Yeah.
All right. So Pawan is asking a very interesting question
Yeah.
from the point of view of your background. He said,
Yeah.
as you said, you went into data science when it was not a hot topic, basically.
Yeah. Yeah.
So he's asking what made you take such a challenging risk or sort of challenge in your career at that point?
This is, I like. It's not one straightforward answer to that, Pawan. I would say, Pawan. Is that Pawan? Pawan
Yes,
did
yes,
ask
it's
question.
Pawan.
Yeah.
Yeah.
Yeah. So, Pawan, if I to be completely honest with you, when I was working in British Telecom in India, I did realize because the very first organization that you work, right, you do get to know. I mean, I was lucky enough to understand that what my calling is. I could understand that. All right, that I do have a knack for something in this area. All right. And then I started reading a lot about it as well. I had no idea that this is going to become this big in 2012, 13. I had no idea this will become too big or big enough for me to actually take a change of course or my career altogether. Uh, but I think you got to do what you got to do, right? So you have to take the risk. You have to take the risk at some point of time. If you are not happy with what you are doing, if you think, and this is very a cliche answer, and I would not want to sound cliche at all about this, but as cliche as it is very true as well. You have to know that if you are not happy with what you're doing, then you really have to know what you are happy with, right? I mean, getting to know what you're not happy with is one thing, but you got to be very clear as to what you're happy with as well. So you need to know that calling, and it's extremely extremely important to do that. So somewhere I think it was my calling, and I could understand that, okay, or I'm able to understand the patterns, the data, and everything. So that is something which you have to know. And the earlier the better it is. For me, it wasn't that early. I would say I took a lot of setbacks in my life, professionally and personally as well, to reach where I'm at right now. And that's why I can very clearly answer this, that you have to know. You got to take the risk. You have to. I mean, if you don't take the risk, then I don't know who else will help you. You have to take the risk.
Yeah, I guess the question won't be able to answer better than this. So yeah. Okay.
Thank you.
So
Yeah.
next is a question from Sanjay. He's asking something particular for the supply chain industry as well. He's asking what are some algorithms that you have seen that works best in this
Mhm.
particular field as to give you the maximum output and efficiency and sort of reduce the turnover time in this field.
In which area is it is specific asking?
Just in supply chain management.
Yeah, so supply chain management, to be very honest, is what exactly I've mentioned here on the screen as well. I have seen that, but to be very honest, this is a very problem dependent. What do you call model? The one, like for example, the demand forecasting that I'm doing, Facebook Profit for me right now is performing the best, and LSTM is performing the best, right? So now a model like Sarimax or Arima or Arimax, these are the models which sometimes work, sometimes they do not, and I'm struggling with Sarimax right now quite a lot, which has worked for me earlier in some of the earlier situations as well. So, but I would say if you are to be firing in the dark, go ahead with Facebook Profit and LSTM. That'll probably, there's a high chance that it'll work. It'll probably work. Yeah. But it is important that you do understand that when you're working with a particular model, like for example Facebook Profit, in this example that I say, you have to know what are the parameters that you're working with, because have a detailed read about the model, as to what are the parameters involved, what are the things that you can change, what are the things that you cannot change. There are quite a lot of parameters. I don't know yet. I still have to read about it, because yesterday I was doing tuning all that, and I did not know that what they meant. So LSTM has worked for me. You can give that a try. Facebook Profit is a good model. You can give that a try as well. Yeah.
Mm. I hope that answers your question. Next up, we have a question from Shrikant, and he's sort of asking the age-old question of that haunts every data scientist basically.
Yeah.
He's asking, how will I know which model or algorithm that I need to go for
Yep.
solving any particular problem? So I guess why don't you share your thought process on trial and testing and how to get to the best algorithm?
Um, See, first of all, again, going back to the very basic and the fundamental question itself, what are you trying to solve, right? And what are you trying to achieve? When you get a very clear cut answer of what you're trying to achieve, right, your search for the algorithm would always narrow down, right? So, my approach always is and I've seen the world of technology is moving so quick and so fast, right, that there's so much on the internet these days, that you do once you start researching, you'd get to know that what are the top trending models, what are the models that is doing well in a particular area. So that is one different aspect. But first of all, you need to be very clear, what is the question that you're trying to solve, what is that you're trying to achieve, right? So that is one aspect. The second aspect is doing quite a bit of analysis and feature engineering, right? Now, feature engineering is a very important part. A lot of people underestimate that aspect, but feature engineering is an extremely important aspect to which will actually guide you to the direction of finding the right models. Now, these days, there are packages like PyCaret, like for example, in time series modeling, there's something which is called PyCaret, right? You use PyCaret and that gives you actually the best model that you can use for a particular situation. Now, now, before you go on to that, also, it is also very important for you to understand that you have a very deep, clear understanding of how a model works, right? Because if you wouldn't know how a model works mathematically and from a programmable perspective as well, you'd always be in the dark of what you want to really want to achieve. So the basic algorithm for the models has to be clear in your mind to actually help you narrow down your approach for solving a problem. So spend time to understand the mathematics and the statistics behind a particular model to first of all question the answer of the problem that you're trying to solve, right? So that is very important. So it's a very genuine question, Shrikant, and I totally appreciate you upfront asking me this. But before you actually go into a practical world, this is one of the biggest questions which haunts a lot of data scientists: that which is the model that I should try, right?
Yeah.
But it's a process. You have to understand a lot of things before you actually arrive onto, and it'll guide you. The process itself will guide you in that direction. So yeah, but there's no one specific model that you can try. You'll have to try quite a few models to actually ultimately then reach to a point that, yeah, okay, all right. So currently, when I am working on models, I have 16 models working parallelly on my screen to see which one is giving me the right output. So every day at the end of it, my GPU usage is so high. My lead always asks me, "What are you doing?" So I can't answer. So that's how it is. So yeah.
Mhm. Okay, I hope that that answer helps you, Shrikant. And now I can see a lot more questions in the chat and in the Q&A section as well. But let's just continue on with the presentation first, and then we'll come back to the questions.
Yeah, yeah,
All right.
sure.
All
Yeah.
right. So let's move on.
Yes. So now the cloud technology for supply chain, right? So cloud technology, as you guys would be a bit familiar with, it's a collaborative platform for different entities in the supply chain to share data in real time, enabling faster decision making and improving overall efficiency, right? So if I put this in very simple terms, I just give you guys the concept of ADF, right? So the different data centers which are working on a cloud technology, you have to move. So I'm giving the very core of how this works, right? So bringing all of that to data from the data cores to the Azure ML platform, which again is a cloud platform where you are given higher GPU access for your models to run, for the data to join, for the analysis to happen. So there's a lot of big data that you're working on, right? So you need to have a very efficient setup. You cannot do this locally at all, right? So you need to have a higher GPU access, a stronger what do you call integration of the platforms for not just the not just for the models to work, but for what do you call the all for all the analysis for the clustering
Abhas, I guess we lost your voice. Can you just check it once?
Can you hear me?
Oh, yeah, now we can.
Yeah.
All right.
Sorry about
Yeah,
that.
no
So
worries.
yeah. Yeah, it's so in very essential terms, it's that. Now there's also I'm not really sure what leads to onto the next slide, but if you can switch to the next slide, yes, I'll just have a look. Yeah. So can you move on to the next slide as well? I just want to have a look as to where we are at. Yeah. So wouldn't want to what do you call confuse with a lot of things here, but the Azure Data Factory. So I'm talking more so here from the Microsoft Azure cloud platform perspective. That is because I have worked more on that. AWS has been is something which I haven't worked a lot, but I think to be very honest, most of these cloud technology performs areas perform in probably a bit of the same similar manner. So ADF Azure Data Factory, as I mentioned earlier, brings the data in Azure ML platform. You do all the clustering and getting together all the data, and then one thing important here to understand is that you can either work on a snapshot of the data or you can work on a dynamic data, right? Now, when you are setting up a pipeline for for a snapshot of the data, by snapshot of the data, I mean, so when you are creating a platform, when you're creating a pipeline, you have the option of either creating a snapshot of the data or you can do it on a dynamic data. So on a snapshot of the data, you do specifically define when you are creating a pipeline that I need the data from this to this. But when you're working on dynamic data, you give the freedom for the pipeline to actually keep feeding the data from the data course onto the Azure ML platform for you to do any sort of analysis or clustering or anything of that sort. So uh, it is very important to keep a check on the ADF pipeline at regular intervals so that if there are any changes in the tables and the schemas, they can be tracked. So like, for example, there are a lot of upgradations happening on the data cores or the data centers, which you can keep a track through the ADF pipeline, which is feeding the data into the Azure ML platform. So that is something which is very important. Azure ML platform, preferably with a higher compute, is the best platform to perform all the analysis and the cleaning. And I've said this before as well. I was initially working with a lower compute, and was in the best of situations. The notebooks kept crashing and all that. So it's obviously also not easy to request for a higher compute because that incurs quite a lot of cost as well for the organization also. So that is something which you have to keep in mind. And then care should be taken to break down the problems and broadly categorize the notebooks. This is important from the production perspective. This is a very small thing, but works very well in a long term. Right. So what you have to do is that you have to make sure that each and every so one big task broken into different problems, different small problems, and each simple problem has to be dealt in one specific notebook. That actually helps you to keep saving the output from every notebook into your into your local data set. Like for example, be it a Parquet file or a CSV file or whatever you want to do. I generally make sure that I save the data as a Parquet file. If you guys are not aware of what Parquet file means, it's pretty much like a CSV file, but easier to work with in Azure on the Azure ML platform. So save the data on a Parquet format, keep reading that, but then solve that small problem, go on to other notebook, solve the other problem, get the output from that notebook, move on to the third notebook. So it is a very efficient way of actually working, and this is something which I've learned on my way as well. So so that is very important. And I'm not sure if on my next slide, Yash, if we can move on to the next slide, please. If you would see, yeah, and on the next slide, please. Yes. So Databricks. So Databricks is something which. So sorry, if we can go back, again, Yash, and one more back. Yeah. Next. Sorry. Yes. Move on to the next slide, please. Yeah, this one. So this I pretty much explained to you guys. So we prepare the data. We use the AML services to build the model, do all the feature engineering and everything. We train and test the model there, and then we register and manage the model. We package and do the validation, and we deploy and keep monitoring it. So now this is the general um, way of an end-to-end of a data science um, problem solution, right? But this doesn't end here, right? So once you validate, once you deploy, once you keep on monitoring, you also have to make sure. So there's something which is called as model massaging as well. So there are times when you have to offload the whole model from the production, and you massage it. By massaging, you mean you check if there has been any change from the main data core itself leading into Azure ML, if the quality of the data has changed or not, if the model accuracy, if there is any sort of, if the model accuracy has changed quite significantly or not, if there is an underfit or not, if the model is overfitting or not. These kind of things that you have to do. So those sort of breakdowns you have to know as to when, like for example, different organizations and different missions have defined timeline as to when they go on offloading it from a production, massage it, and keep it back together again for from productionizing it. If at all we see that that probably model is not working better, so we remove that. We do some other sort of model, but so a lot of things that work in parallel after this whole process of deployment ends. Yeah, so we can move on to the next slide, please. Yeah, and Azure Databricks. Azure Databricks is a pretty useful tool these days as well. One to have in their in their knowledge as well. This is a very interesting area these days and to understand. Azure Databricks is very helpful to perform the parallel computing on huge data sets. So, like for example, on the Azure ML platform, sometimes is difficult to manage very huge data sets. So what we go on using is the Databricks, which uses the Spark technology. So similar to Pandas, we have Sparks there. The code is pretty much the same what you use in Python, using Pandas and all the other things. But there are some syntactical changes that you have to do. But there are these days what do you call libraries which actually just convert your Python notebook from Azure ML onto Android Databricks. So that is something which is very interesting and very helpful for faster decisions making and all that. So this is something which I would recommend you guys to learn. This is going to be pretty big in the coming very near future. So yeah, so parallel computing is the way to go in the very near future. So I'd recommend that. Yeah, we can move ahead. Yes. Uh, this something is you can have a look if you want to. There's quite a lot of things going in there, but pretty much what I've explained, the Databricks and the Azure SQL data warehouse, and then the Power BI dashboard is something which the business uses sometimes, or they are reliant more on the Excel sheet. It's all that. So this is all the coverage of the supply chain analytics in totality, and not every supply chain works in pretty much this sort of a schematic representation, but most of them actually do. So yeah, being conscious of the time, I want that we can move ahead. So yeah, that pretty much is everything that I wanted to cover. And being conscious of the time, I would request Yash if there is any questions that you would want to ask, and I'm happy to go overboard the time as well, and I'm happy to answer the questions as well.
Yeah, sure. I guess that is what everyone else is also waiting for, because I'm seeing a
Yeah,
lot
yeah.
of questions floating in.
Oh, sure, sure. No worries. Go ahead.
Okay, there's a question from Vedya. She's asking again something very specific from the supply chain management industry. She's asking, what are some bottlenecks that you have identified while using ML in supply chain management? Basically, what are some things that ML was not able to solve? Basically,
ML was not able to solve. Thankfully, up until now, it has been able to solve quite a few things that we've been trying to do. But to going on to more of a fundamental question onto that to so where the question is coming from, is more so what do you call the data problem itself at the core of it. If the data does not, it's you know how it is, right? The bad data, the model is bad, right? So a lot of things are data dependent. Uh, Sometimes the data is in itself so complex that what you are trying to achieve, um, it 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 takes a lot of time sometimes to actually code that and resolve that in a in Azure ML. All right, but that is the sort of challenge you would actually face in any sort of platform, right? So, like for example, I can give you a quick example there. Like for example, in a time series model, uh, when the data is fed into the model expects a continuation of the dates, right? This is something which is not known to a lot of people. And the real world data is where a lot of dates are not continuous. Like, for example, an item is sold particularly on one particular store in one particular day. Let's say 6 items are sold that particular SKU, and they're not sold for the next 3 days, and they're sold again on the, let's say, seventh day, or let's say on the eighth day, right? So there is a break in the pattern. Now that break in the date has to be filled. So it has to be a date fill that you have to do. Sounds very easy, right? But it is not. It is not to code that in Azure ML. It was quite a challenging task. It took me about, and I'm very honest about these kind of things. I've worked in this area, but I still say I took about a week time to actually figure that problem out. I was like, why is this so hard? I mean, I don't understand. So you do keep coming with these, keep coming across with these sort of problems, and you're trying to solve them, and it's not easy. It's not easy. So yeah, this is one example I would give you, but there are a lot of other problems that you come across. Hopefully I've answered on the same line as what the question was asked, but I'm trying to make it as practical as possible. So
yeah, yeah,
uh, so,
absolutely.
so
And
yeah,
I
apologies if
can,
I was not answered the right way. Yeah.
yeah, and I can, I can easily relate to what you just said, because sometimes people, when they think about ML and AI, they think, okay, this field is hard because coding something that big is really hard, but they don't
Yeah.
understand that those small little nitty gritties, that is where the
Yeah.
actual problem is.
Exactly. Very very rightly said, Yash. Very rightly said. Yep.
All right. So we have another question from Mahesh. He's saying that I have a lot of experience in the manufacturing domain, and now I'm preparing for the career transformation, and already enrolled in a course here at with us. So
Mhm.
I would like to know, how can I prepare myself apart from the course and adopt to these things basically. So basically, I guess he's asking, he now can be sure that he will get the technical knowledge from the course that he has, but
Yep.
are there any extra things that he should work on?
Um, what really worked for me, I would say, is when you are actually when I was just actually studying, when I was doing my master's, right, in data science, I was doing the research work. When I was doing that, a lot of things which Like for example, the assignments or anything that we were getting as well, then itself were of a very high quality as well. The problems that we are trying to solve or the assignments that we're getting was of a very high quality, which is great. But what really happened was that when I actually went on entering a competition, so I went on to entering a competition outside my studies, but when I actually went on dealing with the real world data, um, could I then really understand that this is not easy? It's not just it's not forget about forget about deployment, forget about everything. You just I mean the very basic of data cleaning itself, and we all who are trying to get into this area, we all do understand and never underestimate the this whole problem of data cleaning, because that is something which you will probably to give a typical example, my mission is started my mission started December 2022. It was to end in June. Up until last week I was cleaning the data. So 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 you do understand what the problem is, right? So coming back to the question again, I would say it's very important for anyone who is enrolled in a course to actually go on solving a real world data. And when somebody says go on trying and solve a real world data, Kaggle competitions is something which you can actually go and enroll yourself, give it a try, just enroll yourself, do a modeling, and see where you are at, right? That will give you a really the taste of actually what you're going to deal with in the real world problem, and that I would say is about 30% of what you would deal in Kaggle, because once you start working in the practical world, there are a lot of other problems also that you that you deal with, which are inclusive of admin problems and stakeholder management and all that sort of things also that you would have to manage. But yeah, to again answer that, go on doing some of the competitions online which are available, and don't fear. There's a very high chance that you would fail for about 10 times, 20 times for sure. I'll tell you. Your accuracy wouldn't even reach 10%, 20%. But keep trying. Do that. That's very helpful. That's extremely helpful. Kaggle competitions. If I'm not sure if how many of you guys are aware about it, but Kaggle, Kaggle, is a great platform for you to test yourself on the real world data. So apart from your academics, you can go and do that as well.
Mm. Okay, so I hope that answered your question, Mahesh. And we have another very interesting question from Reshma here.
Yep.
She's asking that if you are targeting a DS role in a big MNC, is it safe to say that excelling in one thing and having basic knowledge of others will work? Because there are a lot of technologies today that are evolving in this field. So do we have to
Mhm.
master them all, or we can have a basic understanding of everything and master one, basically?
Um, I think what you are saying is actually that worked for me as well. I was good with algorithms. I was good with SQL, but I was not very good with let's say stats. Yeah, I mean, I was not the best with stats. I would say I was not very good with core programming, and and you are right. I mean, platforms are something which I would say is something which you will learn on the job. There are a lot of like for example, Azure ML I knew. Databricks is something which I hadn't really worked on. That is something which I worked on the job. So you don't have to worry about the platforms and all, but yeah, you have to be good at two or three of the very core things. Like for example, you have got to be um, very comfortable with SQL. You got to be very comfortable with what do you call coding in Python. You got to be comfortable with that. Algorithms and these are the sort of things. The two things we are working here, we are talking about here, right? Platforms is one, and any of the MNCs, platforms is one, but your core knowledge about something is a different thing altogether. So platforms are something which you would learn as you go in some of the organizations and in quite a few of the organizations. I was lucky enough that it happened. Sometimes I wasn't that lucky because in consultancies it works a little differently. But but I would say the some of the core things which are expected from a data scientist: to be good at algorithms, either be comfortable with coding in Python, with pandas, with libraries, functions, writing functions. These are the things that you have to be comfortable to work with, to actually work in a big reputed MNC. So yeah, hope I answered that correctly. Yeah.
Yeah, great. So we'll have one final question from Harsharan, and
Yep.
then I guess we'll let you leave because we won't, no, don't want to keep you out for
It's okay.
waiting for
It's
so
okay.
long.
No worries. Yes. But yeah, I'll be happy to answer that. But the questions that you say that are still pending, that I've not been able to answer because of the lack of time, or probably I expanded my whole session a little too long. Maybe I went a little too detailed. Maybe. But I'm happy to answer any of the questions which are pending. You can mail them to me, and I'll be more than happy to answer anything that I can, because I know the journey that I've been through, so I can. I'm happy to answer that. Yes. Yes. Please go ahead. Yes. Yeah.
Yeah, sure. We'll share your email address in the chat as well.
Yep. Yeah. Sure.
That's what you want. All right.
Yeah. Yeah.
So from the question from Harshanan is, what's the focus in inventory management, or maybe he's asking which projects that he can take if he wants to move into this field, basically. Let's say he wants
Uh,
to take up a role of data science in supply chain management. What are some projects that he can aim for at this point?
is he studying right now? Yeah.
Yes, yeah,
Okay. Yeah. So see, the thing is that when you if I've understood the question correctly, when you enter an organization, all right, uh, as a data scientist, they do not really look at what kind of I mean, if you are starting as a junior data scientist, it's a different sort of thing. If you are coming as a data scientist, or if you're joining as a senior data scientist role, they do look at your past experience as to what you have worked and in which area you have worked. Like, for example, um, I was working in FMCG in supply chain, so that actually helped me in working in this mission. But they do not actually go on looking at what you have worked on. Right, they would simply just go on assigning you the mission, and they would not really care about, I mean, they would really regard your experience in past of working. Let's say if I worked in banking, I had worked in banking for about 6 years, and can you guys hear me?
yeah. Now it's clear. Yeah,
Yeah, yeah. Sorry. So what I was saying is that it's a case to case basis, right? So starting, they did not really care about what. Um, they would not really go on asking that what do you want.
yeah,
They would simply give you what the mission requires, and then they will ask you to learn about the mission, understand the problem of it, and then just jump into it. So yeah, I'm not sure if I've answered that very correctly or not, but that's what the sense of the question that was, that it came to me,
mhm.
and I try and understand. If I have not made sense, please let me know. I'll be happy to answer again, or for that matter, I'll respond on my email as well. So yeah,
Yeah, sure. That is really great from you as well, Abbas.
yeah,
Thanks for doing that.
no worries, no worries.
Yeah, so let's just conclude at this point. Everyone, I know that we would like to keep Abbas for the entire day with us, but as we can understand, there's always parting time, right?
Yeah,
So, yeah, again,
yeah,
Abbas, from the entire team of Insight, thank you for joining us here. And it was really lovely hearing you, tell us all those
no.
information.
Thank you so much. Thank you so much, Harshita. Thank you so much, yes, for organizing such a wonderful session. I am happy that I could share any sort of little knowledge that I've gathered along my journey as a data scientist, as working in the data field. But as I wouldn't give too many words of encouragement here, but I would just say that just stick to it. Just keep pushing yourself. This is a very interesting area of work, and don't give up. Just focus yourself, and then just keep working at it. And I'm sure all of you guys would get what you want, and you all will be the pioneers of data scientists community in India, and everywhere in the world. So all the best. All the best.
Yeah. Thank you, Abbas. Thank you for joining
Thank
in.
you. Thank you, guys. Thank you so much. Thank you. Bye.
Bye. Okay, guys. With that, I would like everyone to fill up the feedback form as always. And I hope that everyone liked